Hello, geometry. Welcome to video 2 for lesson 4.6 on overlapping triangles. We got two problems, and let's start here with problem 3. It says we need to write a proof to prove that triangle BFE, so this like obtuse triangle here, is congruent to triangle CEF, this one here. Okay. Now, in order to do this, okay, I think that we have to prove another pair of triangles congruent. And the reason I think that is because look at the given. Are these given pieces of information a part of the two triangles I want to prove congruent? And the answer is no. They're a part of this outside triangle ABF, and they're also part of this bigger triangle ABE, right? That overlaps with DCF. I think I want to prove that those two triangles are congruent. And the reason is, I think that there's a pair of corresponding parts from those two triangles that are also a part of the triangles I want to prove congruent. Alright, so again, I've been doing proofs for a while, so I kind of know what to think about, but to give you a heads up, right, whatever you're given, focus on a triangle involving the given things. So again, we're going to focus on triangle, and I'll draw them separately right here. Triangle ABE, ABE, and then DCF. DCF. Okay, so I am given that AB is congruent to DC. I'm given that now watch this. On each of these sides, AF is like right here. AF is congruent to DE, and like DE is right here. Okay? But very similar to the last problem we did, I think I also know that FE is congruent to EF because that's the overlapping part on that side. And if I combine this 2 marked congruent side with this 3, I believe we're going to know that AE is congruent to DE, right? So that'll give me a second side in these two triangles. And then you're given angle A is congruent to angle D. So you're going to be able to prove these two triangles congruent by side, angle, side. So let's do that first, okay? So we are given all this information. So segment AB is congruent to segment DC. Segment AF is congruent to segment DE. Angle A is congruent to angle D. That was all given to us. So now in green, because I did it in green, I'm going to take this statement right here, right? I'm going to say, okay, well, if, I'm sorry, not if. We know that segment FE is congruent to segment EF, and that's by the reflexive property. And again, that's the overlapping side, that's the shared side. So if we take AF and add FE, if we take DE and add EF, we're going to get 2 more congruent segments. So we are going to know that segment AE, this big long side, is going to be congruent to segment DE, this big long side. I'm sorry, DF. I apologize, DF. DF, right there, DF. And that is basically by the angle addition, or I'm sorry, segment addition postulate. And again, very similar to what we did in the last problem. You know, it also involves some substitutions because really, you know, when you combine, when you add, you're saying that AF plus FE is the same as DE plus EF. And of course, AF plus FE is AE, DE plus EF is DF, right? So it's like a hybrid of segment addition postulate and some substitution, all right? So again, we're not being very formal. If you had to do a formal proof, it'd kind of walk you through it. So we now know that these two triangles are congruent. So triangle, I'll use ABE is congruent to triangle DCF, and that's by side angle side congruence. So now, I'm now going to take apart the two triangles I want to prove congruent. So I'll put triangle BFE right there, BFE, and triangle CEF right there, CEF. So we kind of already said that FE and EF are congruent. So we have this pair of sides. Okay. I think we let's see. We also know that all the corresponding parts of these two triangles are congruent because the two triangles are congruent. So if we look, what overlapping parts are in the blue triangles? Well, I see that BE, this side here, I'll mark with 4, is right there. And I know that CF, I'll mark this side with 4, is right here. So those two sides are corresponding parts of these two triangles. They're going to be congruent. I also know that in this picture, the angle here at E, call it BEA, right? This angle right here, BEA, is going to be congruent to CFD, which is this angle right here. That's these two angles right here, the angle here at F and the angle here at E. And now if you look, for this triangle, we have side, angle, side. These two triangles will be congruent by side, angle, side. So it comes from here, where? This one right here. And it also comes from the corresponding parts of these two triangles. So because these two triangles are congruent, so we now know that segment BE is congruent to segment CF, and angle BEA, or AEB, whatever, is congruent to angle CFD. And that is by CPCTC. Well, with these three pieces of information, we can now say that those two triangles, thus, triangle BFE is congruent to triangle CEF. And that is also by side angle side congruence. So what this problem tells us is that we can use other pairs of corresponding, other pairs of congruent triangles to prove more pairs of congruent triangles. Right? That's when it gets tough. All right. So if that was a hard proof, it's going to be, right? You got to have more practice. But all that overlapping, right? Look at this picture. How many triangles are there? There's tons. Okay. All right. Last problem here. All right. So it says a city runs 3 triangular bus routes to various attractions. How can you draw a separate triangle for each route? Are any of the routes the same length? Okay. So I'm going to use green, purple, and red. So let's use green for the green route. So the green route stops. So it's going to start at the Science Museum, right? So there's the Science Museum. It's going to go to the theater. It's going to go to the History Museum. It's going to go to the zoo. It's going to go to the Rose Garden and back to the Science Museum. So it is this picture right here. Now, we have a 2.1 and a 1.4, so that's 3.5. 2.1, 1.4. We also have on this side a 1.2 and a 0.9, that's 2.1. 1.2, 0.9. But we don't know this missing side. Okay, but we don't. Okay, but this is the green triangle. All right. Well, I don't have to. Why did I do that green? I don't know why I did that, but it's fine. Okay, let's do the purple route now. Okay, so the purple route starts at the water park, goes to the art museum, which is down here, art museum. Then it goes to the concert hall. Then it goes to the science museum, comes back down to the zoo, and then back to the water park. So the purple is this triangle, purple. So I know that this side right here is 6, 1.2, and 1.6. That's 6 and 2.8. That's 8.8. Oh, I'm sorry. Not 6. I apologize. Right? I covered this up. It's 1.6. Oof, close. So this is not 8.8. It's 1.6, 1.2, and 1.6. That is 2.8, 1.6. That's 4.4. So 1.6, 1.2, 1.6. This side over here is 1.4, 1.1, 1.4. That's 2.5 and 1.4. That's 3.9. And then this bottom side we know is 0.3, 0.2, and 1.8. So that's 0.5 and 1.8 is 2.3. Oh no, I'm sorry. Oh, my fault. The 0.3 is down here. I'm sorry. It's not 0.3. It's 0.9. Sorry, again, just trying to read the graph. My bad. So it's 0.9, 0.2, and 1.8. So this is a 2.9. Sorry. Okay. So notice that I don't believe these two triangles are going to be congruent, right? You know, they won't have the same routes, because notice that this has a right angle and this purple triangle is not. So I'm thinking that one's not right. And now the red route. I'm going to come over here and do it. So the red route starts at the football museum. It goes to the zoo. Then it goes to the theater. Then it goes to the science museum. Then it comes to the Rose Garden. And then it comes back to the football stadium. So it's this triangle here. This is the red triangle. Notice it does have a right angle. All right, so let's see if we know any sides. Well, this is just one side, 2.1, right there. This side right here, I don't think we know. Right, there's no marking here, none here, none here. So for some reason, they didn't measure that part. This other side, I think we know. I think it's a 1.2, a 0.9, a 1.1, and a 0.3. So 1.2 and 0.9 is 2.1. 2.1 and 1.1 is 3.2. 3.2 and 0.3 is 3.5. Right? So the question is, are any of these triangles congruent? Well, look here at the green and red. I know my red's bigger. But notice that this is a right triangle. They're both right triangles. Okay? Notice that 2.1 and 2.1, that's a pair of legs. So we have the right triangle, we have a pair of legs, and we have the hypotenuse, 3.5 and 3.5. These two triangles are congruent by HL. So in this problem, the green and red are the same. And that is by HL congruence. So again, I think they stuck that one in here just because these triangles do overlap, right? And it's kind of hard to decipher. All right, great. So this was the last lesson in topic 4. So do your best on this lesson and get ready for that assessment coming up. All right, thanks for watching.